9:53 in the morning. Daytona Beach, Florida. A single-engine trainer at 3,000 feet. A commercial Checkride, half-finished. 28 flight hours earlier, a mechanic had signed that airplane off as airworthy. He was not wrong. The left wing was already more than 90% of the way through braking, and there was nothing on that airplane he could have looked at to find it. Have you ever taken an aircraft back after an annual and wondered what that inspection actually covered? Put it in the comments. This is the kind of thing Sky Ranch takes apart. Subscribe so you catch the next one. The airplane was a Piper Arrow, registration November 106th. Echo Romeo, built in 2007, and flown by Embry-Riddle Aeronautical University. Embry-Riddle runs one of the largest collegiate training fleets in the United States. Airplanes there do not sit in a hangar waiting for a nice weekend. They fly all day, most days, in the hands of people who are still learning by definition. That is not a criticism of the school. It is a description of what a training airplane is for, and it is the reason the wear on that airframe ran out ahead of the rulebook written to catch it. By April of 2018, it had 7,690.6 hours on the airframe. It also had 33,276 landings. Sit with that second number. 33,000 landings against 7,000 hours is more than 4 landings for every hour the airplane was in the air. A privately owned Cherokee flying 100-mile trips might land once an hour. This one spent its whole life in the pattern. Around, down, around again, all day for 11 years. There is a question the aviation press asked after this accident and never really answered. Do airplanes used for training get abused in ways personal airplanes never see? Isabel Goya put it in print at Plane and Pilot, and it is the right question because a landing is not a gentle event for a wing spar. Every touchdown loads the structure and then unloads it. Every go-around does it again. Metal does not care how hard any single one of those cycles was. It counts them. Fatigue is not a strength problem. A spar cap that fails from fatigue was never overloaded. It was loaded and unloaded tens of thousands of times, and at some microscopic point in the metal, the crystal structure gave up before the rest of it did. Once a crack starts, every further cycle drives it a little deeper. It never heals, and every hour in the air makes it longer. The airplane gives no sign that any of it is happening, and it starts where the stress concentrates, which is at a hole. Drill a hole through a loaded piece of aluminum, and the load that used to run straight through has to bend around the opening, and it piles up hard at the edge of the bore. That is why the crack in this airplane started where it did. The bolt hole was not a weak spot by accident. It is the exact place a designer already knows the load will crowd. In the left seat that morning was Zachary Capra. 25 years old, a Navy veteran, a student working toward his commercial certificate. In the right seat was John Azma. 61, an airline transport pilot and an examiner the FAA had designated to give that check ride. A commercial check ride is not a training flight. It is the exam that turns flying from a hobby into a job, and it is flown to tighter tolerances than anything a private pilot is ever asked for. Steep spirals, chandelles, lazy eights, maneuvers that roll a wing into a bank and then load the airplane up and hold it there. Capra had done the work to get to that morning. Azma had sat through hundreds of them. Neither of them did anything wrong. The last annual inspection had been on the 21st of March at 7,762.3 hours. No discrepancies, nothing written up, a clean sheet. An annual is not a small job. A mechanic opens inspection panels, pulls cowlings, checks control cables, runs a compression test on every cylinder, looks over the landing gear, and works down a list that runs to dozens of items written into the federal regulations. On a Cherokee, it is a day or more of real work by somebody who does this for a living. Then the mechanic signs the logbook, and that signature carries legal weight. 2 weeks and 28 flight hours later, the left wing came off. A clean sheet on an airplane that was 14 days from losing a wing. That combination is the thing I cannot get past. Engine failures give you something to do. A glide, a checklist, a field to aim for, a procedure written by somebody who thought about this before you needed it. Nothing is written for a wing leaving. The National Transportation Safety Board took the wreckage apart and put the spar under a microscope, and the probable cause they published is worth reading slowly because it does something accident reports almost never do. It does not blame anyone in the airplane. It says the cracks grew from the flight loads and landing cycles of a training airplane. Then it says this: previously established inspection criteria were insufficient to detect the fatigue crack before it grew to a critical size. That is a federal agency writing down that the inspection system was not capable of finding this. Not that a mechanic rushed it, and not that anyone cut a corner. The system itself could not have worked. There is a second half to that probable cause most people skip past. The cracking was not confined to the spar cap, it was in the doublers as well, the reinforcing plates stacked against the cap at the attachment point. The board's wording is extensive fatigue cracking in the left wing, main spar, lower cap, and doublers. So this was never one crack in one piece of metal. It had worked its way through the stack of parts that exists specifically to make that joint stronger than it needs to be. The laboratory work took more than a year. The final report was not published until the 6th of September 2019, 17 months after 2 people died on a Wednesday morning in Florida. The wing had been failing for years. What the board had to explain was where a failure that large had been hiding. Every Cherokee and every Arrow carries its wing on a main spar, and that spar bolts to the fuselage through a row of holes drilled into the lower spar cap. The spar cap is the thick aluminum strip along the bottom of the spar. It is the part that carries the load when the wing bends. Bolts go through the holes. The bolts get torqued down. Then the wing goes on, the fairings go on, the fuel goes in, and none of it is seen again until somebody takes the wing off the airplane. The crack in that Arrow started in a hole the investigators labeled LC1, lower cap, hole 1, the outboard forward wing attachment bolt hole on the left side. It did not start on the surface of the spar. It started inside the bore of the hole, in the wall of the drilled hole itself, underneath the bolt. Read the sentence the board wrote about that location. The crack's position, they said, would have prevented visible detection from the interior or exterior of the airplane. Interior or exterior? Both. There is no angle from which that crack is visible. Paul New, who runs Tennessee Aircraft Services, put the shop floor version of it plainly. There is no way to cut an inspection panel that gets you to that area. The geometry will not allow it. To put a human eye on that hole, the wing comes off the airplane, and wing removal alone is about 16 man-hours before anybody has inspected anything. Which is why the board said the only reliable method would have been a non-destructive inspection procedure, such as a high-frequency eddy current bolt hole inspection. That means pulling the bolt out, sliding a probe down the empty hole, and reading a change in an electromagnetic field at the point where the metal stops being continuous. You are not looking for the crack. You are listening for it. And the thing being listened for is astonishingly small. Inspection houses working these spars report finding cracks as short as 0.010 of an inch, 1/4 millimeter, inside a hole, underneath a bolt, on an airplane that flies perfectly and sounds perfect and gives its owner no reason at all to go looking. This is the part I think gets lost every time this story comes around. An annual inspection is not a search of the airplane. It is a search of the parts of the airplane a person can physically reach. Those two things are not the same, and almost nobody says so out loud because saying it out loud is uncomfortable for everyone in the hangar. The crack grew until fatigue features covered more than 90% of the cross-section of that spar cap. That is the figure in the final report. 90% gone, and the airplane still passed a walk-around. The FAA's own description of what it was dealing with is worth hearing in the agency's words. The unsafe condition, they wrote, if not addressed, could result in the wing separating from the fuselage in flight. Regulators do not write sentences like that casually. That is the language you reach for when a failure mode has no recovery, no warning, and no procedure, and when the only open question left is, how many airplanes are carrying it? This had happened before. On the 30th of March, 1987, the left wing of a Piper Cherokee separated in flight near Marlin, Texas. The FAA issued an airworthiness directive 36 days later. The airplane near Marlin was a PA-28R-181, and it came apart in the same part of the airframe. 36 days after it happened, the FAA had a directive in the field written before anyone had surveyed the fleet. 36 days. Hold that number, because the second half of this story runs on a very different clock. Now, the part that changes the shape of everything before it. When the investigators finished with the left wing, they went and looked at the right one. The wing that was still attached. The wing that rode the airplane down. It was cracking too. Fatigue, up to 47 thousandths of an inch deep, in the same lower spar cap. Which wing came off first that morning was a coin toss. They did not stop there. Embry-Riddle had a sister ship, serial number 2844135, built alongside the accident airplane. They pulled the bolts and ran the probe. There was a crack at the same hole, 40 thousandths of an inch long, 40 thousandths deep, about a millimeter. That airplane had been sitting on the ramp with a clean logbook, flying students. All the way up to the morning, somebody finally looked inside the hole. A millimeter is the distance between a maintenance item and a funeral. Which part hits harder for you, that they found it, or that they only found it because 2 people had already died? 9 more Arrows from other operators were inspected in the weeks that followed, and not one of them showed an indication. Which opened the question the last 8 years have been spent arguing about. How many cracked wings are out there, and how hard should anyone be forced to look? Piper went hunting for the cause inside its own factory and found it. The spar cap on those airplanes got its dihedral, the upward angle of the wing, from cold bending. Bending aluminum cold locks residual stress into the metal. Piper's engineering conclusion was that residual stress from the spar cold bending process is a significant contributing factor in reducing the fatigue life of the spar bolt holes. New spars are not built that way now. The bend is machined in. Give the company credit for that. They took their own manufacturing process apart and named the flaw in it. Every airplane built the old way is still flying. In January 2021, the FAA published the rule that is still in force today. It covers 5,140 aircraft on the United States Registry. It requires an eddy current inspection once an airframe passes 5,000 factored service hours. It inspects 2 bolt holes. Factored service hours is the point where most private owners stopped reading, and it is worth understanding exactly why. The rule does not count flight hours. It counts hours weighted by how the airplane earned them. An hour flown under a 100-hour inspection cycle, which means commercial and training work, counts as a full hour. An hour flown outside that, which is almost every privately owned Cherokee in the country, counts as 1/17th of an hour. Run it on a real airplane. A privately flown Cherokee with 4,000 hours and no 100-hour inspections scores 235 factored hours against a 5,000-hour threshold. The identical airplane in a flight school scores 4,000. Same metal, same age, same bolt holes, and a 17-to-1 difference in how the rule sees it. That arithmetic is why most owners read the 2021 directive, ran their own numbers, decided it was a flight school problem, and went flying. Then the inspection reports started coming back. More than 2,800 aircraft reported in. Over 100 positive eddy current indications. Roughly a quarter of those turned out to be hull damage or corrosion rather than fatigue at all. When it was sorted out, 6 confirmed fatigue cracks. 6 out of more than 2,800 inspections. About 1 airplane in every 470. Both sides look at that number and see something completely different, and both readings hold up. The Experimental Aircraft Association told the FAA that the inspection data does not support the conclusions the agency drew from it. 6 in 2,800 is a hit rate low enough that the cost and the risk are not carried by the finding. Piper's objection was more specific and more uncomfortable. Pulling those fasteners can itself create a notch, a gouge, a thread mark, something likely to cause a safety or airworthiness hazard. The inspection is capable of manufacturing the flaw it went looking for. And Earl Weiner, then a member of the NTSB, said out loud that on the lower risk models, the risk of disturbing the joint may outweigh the risk of fatigue cracking. The safety board that found the hazard did not endorse the widest possible answer to it. The FAA's reading of the same 6 numbers is one sentence long. Those were 6 wings on their way off. In September 2024, the agency proposed 2 new directives, and this is the point where it stops being somebody else's problem. The first would require inspecting all inner surface bolt holes in the lower spar cap on both wings, not 2 holes, all of them. Sit with what that concedes. In a Federal Register document, the agency is stating that the inspection currently in force does not look everywhere a crack can start. The second proposal rewrites the arithmetic. The divisor moves from 17 down to 3, and on some models down to 2. That privately flown 4,000-hour Cherokee that scored 235 goes to 1,333, or 2,000. Measured against new thresholds that are lower than the old one, not higher. And for the first time, a hard life limit on the spar, not an inspection interval. An ending. Together, the 2 proposals cover 21,522 airplanes. The way out is a reinforcement kit Piper designed, which takes the spar to 25,000 hours. The parts run $4,000. Installation is roughly $20,150 per wing. Call it $44,000 to fix an airplane that is often worth less than the fix. As far as can be verified, neither proposal has been finalized. The comment periods closed in November 2024. 8 years after 2 men died over Daytona Beach, the rule that decides the fate of 21,000 airplanes is still a draft. 36 days in 1987. 8 years and counting now. I am not going to tell you which side of this is right, because nobody has the data to settle it. 6 cracks in 2,800 inspections is either a risk being managed well or a risk being missed, and the only way to find out which is to look inside the holes, nobody has looked inside yet. What the story does settle is smaller and harder to shake. That Arrow passed its annual with a clean sheet 28 flight hours before its wing came off, and the sign-off was accurate. The inspection did exactly what inspections do. It looked where a person is able to look. Airworthy was never a statement about the airplane. It is a statement about where somebody could reach. Once you see that, a logbook stops reading like a guarantee and starts reading like a map of everywhere nobody has been. That is how Sky Ranch reads these airplanes, and there is a lot more of it coming. Subscribe.